Hello all, welcome to the channel Way to Electronics. This video is about IGBT, Insulated Gate Bipolar Transistor. This is a semiconductor switching device which can be used for fast switching with high efficiency in many types of electronic devices. These devices are mostly used in amplifiers for switching or processing complex wave patterns with pulse width modulation. First we shall see what is IGBT. IGBT is a voltage controlled switch. If BJT have a lower conduction losses but have longer switching times, and MOSFETs can be turned off and turned on much faster but their on-state conduction losses are larger. Here the IGBT combines the advantages of MOSFETs and BJTs. It has a higher input impedance like MOSFETs and low on-state conduction losses like BJT. Next we shall see the IGBT symbols. We have P-type and N-type IGBT. Here this is the symbol for IGBT N-type and this is a symbol for IGBT P-type. So it consists of three terminals: collector, emitter and a gate terminal. As I mentioned earlier, IGBT is a fusion between the BJT and MOSFET. Here this symbol which will have the representation of the same, that is input side which will represent the MOSFET with the gate terminal and our output side which have the BJT with the collector and the emitter. Collector and the emitter will be the conduction terminals and gate will be the control terminal with which the switching operation is controlled. Next we shall see the IGBT structure. This is the IGBT structure. So this can be constructed with two equivalent circuit which consist of two transistors and a MOSFET which will gives to the IGBT. So here we can say that the IGBT possesses the output of the combination of PNP with NPN transistor and along with the MOSFET. This IGBT combines the low saturation voltage of a transistor with high input impedance and switching speed of a MOSFET. So the output obtained from this combination which will delivers the output switching and conduction characteristics of bipolar transistor, but the voltage is controlled like a MOSFET. Now we shall see the construction of this IGBT. It consists of three terminals: source, emitter, that is gate, and the drain or a collector, which is attached to the three metal layers, and the metal layer of the gate terminal is insulated from the semiconductor by a layer of silicon dioxide SiO2. This IGBT is constructed with four layers of semiconductor which is sandwiched together. The layer closer to the collector which will be the P plus, and above the P plus we have a N plus, and one layer which is interconnected with the N plus regions, that is P layer. The adjacent N plus and N minus layers which is adjacent to the P plus layer are treated as a single N layer. And next we shall see the junctions. The junction between P plus layer and a N plus layer, we call it as a J2 junction, and the junction we are going to consider J1, that is the junction between N plus and a N or simply a P layer is a J1 junction. Next we shall see the working of the IGBT. In order to understand the working or operation of IGBT, we need to consider this circuit. Consider the voltage VG connected positively to the emitter and the gate terminal. Next, one more voltage source we are going to consider, that is VCC, which is across the emitter and the collector, where the collector is kept positive with respect to the emitter. Due to the voltage source VCC, the junction J1 will be in the forward bias and where the junction J2 will be in the reverse bias. Since J2 is in the reverse bias, there will be no current flows in the IGBT. Initially, we are not going to apply any voltage near the gate terminal. At this stage, the IGBT will be in the non-conductive state. If we increase the gate voltage to some value due to the capacitance effect on the SiO2 layer, the negative ions will get accumulated on the upper side of the layer and the positive ions will get accumulated on the lower side of the SiO2 layer. This will cause the inversion of the negative charge carriers in the P region. When we are going to apply more voltage to the gate terminal, there will be a channel formation near the junction J2, which will flows the current from the collector to the emitter. In this picture, we can see the flow of current, which is represented as a current path. When the gate voltage Vg increased even more, the amount of current flow from the collector to the emitter terminal also increases. So here we can summarize with the points. A positive voltage is applied to the collector with respect to the emitter. The current flows through the N channel in an IGBT cell when a positive voltage applied to the gate emitter terminal is greater than the threshold voltage. Then the IGBT is set to in the on condition. When the gate emitter voltage VCC is removed, that is the IGBT goes to the off condition. So we can say that the gate has a full control over the conduction of the IGBT. Next we shall see the IGBT types. In IGBT we have two types, that is punch through IGBT, PT IGBT, and non punch through IGBT, NP IGBT. What does this punch through IGBT means? The IGBT which consists of a buffer layers in its structure, we call it that as a punch through IGBT or PT IGBT. And the IGBTs that doesn't have any N plus buffer layer are called as a non punch through IGBT or NPT IGBT. Next we have this IV characteristics of IGBT. Here the characteristics will be plotted for the ID and VDS for the different values of VGS. When VGS will be greater than the VGS threshold, the IGBT is in the on condition. If it is lesser than the threshold voltage VGS TH, the IGBT turns off. Next we shall see the IGBT applications. IGBTs are widely used in switching, static power converters, AC motor drives, that is inverters, DC to DC power supplies, that is choppers, UPS systems, solid relays. Thank you.